Okay, again, my name is Christina Staten. I am the project coordinator for the Madison Sediment and Temperature Total Maximum Daily Load project. I'm joined today by Christy Meredith, a TMDL planner at DEQ, as she's a main author of this document. I'm also joined by Moira Davin at DEQ, and she will be helping to facilitate this meeting, as well as David Laufenberg with the Madison Conservation District, who will be giving a portion of the presentation. Thank you for joining us this evening. We're glad to see so many people that are interested in water quality in the Madison River watershed. And I apologize. Hold on here. Okay, I apologize for that. Having technical difficulties. So a little bit about who we are. Christy Meredith and I work for the Montana Department of Environmental Quality, which is a state agency. And part of DEQ's mission is to maintain and improve water health so that we support our recreational enjoyment of water for activities such as fishing and swimming, to ensure that we provide clean drinking water for us, for livestock, and for wildlife, to support aquatic life that live in the streams, such as fish and bugs, and to make sure that water is usable for irrigation purposes to water our crops and our gardens. To further this mission, we develop solutions to reduce pollution entering our waterways. And we do this sometimes in the form of developing total maximum daily load documents. Additionally, DEQ staff provide support to local organizations such as the Madison Conservation District that are working to improve water quality. And for the purposes of this presentation, I will be using the terms water quality and stream health interchangeably, as they mean the same thing. And I hope by the end of this presentation that you've learned a little bit more about water quality in the Madison River watershed, and you're even more interested in maintaining the health of your streams. The purpose of this meeting is to discuss a total maximum daily load document that's available for your review and comment. It's a 30-day public comment period. We're about halfway through. Comment deadline is 5 p.m. on Thursday, August 20th, which is 2 weeks from today. This is a picture of the cover page of the document on the screen. If you've already looked at the document, you've seen that it's a fairly large document, which might be a little daunting to some. So this evening, we want to give you an overview of the contents of the document and to talk about a water quality study that we looked at the effects of excess fine sediment and elevated water temperatures on 20 tributaries to the Madison River. Specifically, I'll be going over a project overview, the goals of this project, and going through the basic water quality planning steps that we take for any project of this type, we being DEQ. Christy Meredith is then going to give a short presentation on how excess fine sediment negatively affects stream health, how we monitored for fine sediment, what our sampling results were, and what total maximum daily loads were written for sediment impairments. She's then going to talk about the same things for elevated water temperatures in the watershed. Then I'm going to come back and talk about how to improve water quality. And David with the Conservation District is going to give a short presentation on ways that you can get involved locally and to talk about some of the projects that the Conservation District has going on. And then at the end of the presentation, I'm going to talk about how the TMDL document is organized and how you can submit comments. So what is the purpose of this project? Why is DEQ writing total maximum daily loads? And I will define what a TMDL is when I go through the 4 main steps to these types of projects. But I just want to give you a little bit more background. and that the state of Montana has a delegated authority under the Federal Clean Water Act to identify streams that are not meeting the state's water quality standards, and those are considered impaired. We also have the authority to develop plans to address these impairments, and that can be done in the form of a total maximum daily load document. Montana state law also requires DEQ to develop TMDLs for waters that are considered impaired by a pollutant, and a pollutant includes sediment and temperature. To date, we have over 75 completed TMDL documents. And on the screen, I have a picture of the cover page of 3 of those documents. The top one being a TMDL document for nutrient, E. coli, and metals impairments for the Madison River watershed. And this document was produced last year. This map of the state of Montana shows in green where those 75 TMDL documents have been completed. And it's important to understand when you're looking at this map that this map actually shows watershed boundaries. Most maps that you might see show county boundaries, but these are actual watersheds. And the Madison is shown here in the bottom left. This map also shows hashed areas where we have TMDL development in progress. So we're working in more areas than just the Madison River watershed. So how did we choose the Madison? Why did we decide to start working here, excuse me. DEQ recognizes that this watershed is a very important economic resource in terms of fishing, tourism, and ranching. There are also multiple active local organizations, including the Conservation District, with an interest in protecting stream health or water quality, as well as an interest in implementing recommendations that are included in the TMDL document for improving water quality. The Madison Conservation District already has a water quality monitoring program in place called the Madison Stream Team. And we have some stream team members on the call today. And a lot of the data that has been collected by the stream team has been used in development of not only these sediment and temperature TMDLs, but also the nutrient and E. coli TMDLs that were produced last year. And on the screen here, I have a picture of their 2018 annual report. And when David gives his presentation, he's going to give more information about how you can get involved with the stream team if you are interested in doing that. So here is a map of the watershed. The Madison River actually forms within Yellowstone National Park. You can see here in the bottom of the map that the river forms where the Gibbon and Firehole rivers converge. The river then flows out of the park into Hebgen Lake and continues flowing north through the town of Ennis. Near Three Forks, it joins with the Jefferson and Gallatin rivers to form the headwaters of the Missouri River. And even though it's not shown on this map, the watershed is divided between Madison and Gallatin counties. And David's going to talk a little bit more about county divisions within the watershed when he gives his presentation. This map shows the streams that we studied for this project, and it only shows the project area. And I meant to mention on this screen that the project area is only the boundary within the state of Montana. We did not study the area within the national park. So this map shows that area that's considered the project area. And these are all of the streams that we looked at, and I'm going to read through them. Starting in the northwest corner near the town of Norris, we looked at Hot Springs Creek. Moving south, we looked at North and South Meadow Creeks. Moore Creek that flows through the town of Ennis. Blaine Spring Creek, where the fish hatchery is located. Wigwam Creek and Ruby Creek. And we looked at the West Fork Madison River and 3 of its tributaries, Buford Creek, Gazelle Creek, and the Elk River. Swinging around the bottom of the map, we looked at Antelope Creek, as well as Watkins and Red Canyon Creeks that are tributaries to Hebgen Lake. Moving north, we looked at Indian Bear and Odell Spring Creeks. Jack Creek, which has multiple restoration projects ongoing right now. work through the Madison Conservation District, Trout Unlimited, and other partners. And then we also looked at Cherry and Elk Creeks. A little bit more about project history. We've been working in this watershed for quite a while. From 2012 to 2015, we conducted water quality sampling, and we also looked at sources of pollution to the 20 tributaries in the Madison River that we studied. In 2016, we took that water quality data that we collected, and we compared it to Montana's water quality standards to determine which streams are not meeting the standards and are considered impaired. Streams that are considered impaired require a total maximum daily load. And in 2019, we published nutrient, E. coli, and metals TMDLs. And I showed a picture of that document's cover page. And this year, we're publishing the sediment and temperature TMDLs. So what were our goals for this project? Excuse me. Our main goal is to provide information that will help protect water quality in the Madison River watershed, as well as provide suggestions for water quality restoration projects. To help achieve these goals, DEQ develops water quality improvement plans, and in this case, it's a total maximum daily load document. So lastly, I want to briefly cover the 4 main planning steps, and I've kind of already discussed these, but I'll go through each one of them. It begins with the establishment of water quality standards, then monitoring and collecting water quality data, developing the solutions, which are total maximum daily loads in this case, and then assisting with implementation of the TMDLs and the water quality restoration suggestions that are included in the TMDL document. So water quality standards are set to protect all the ways that we use water. And as I talked about at the beginning of this presentation, when I discussed DEQ's mission and the uses of water that we want it to protect, those include our recreational uses, protection of aquatic life, and ensuring there's clean drinking water. Water quality standards come in one of 2 forms. They are either numeric, which is a number, or they're narrative, which is a description of the way that the water should be maintained. Christy Meredith, when she gives her presentation, will talk specifically about the narrative water quality standards that are in place for sediment and temperature. So the next step is water quality monitoring. As I said, we collect the data and compare it to water quality standards. Streams that are not meeting water quality standards are considered impaired and require a TMDL. A lot of people, when they hear the term water quality monitoring, they probably think of someone dipping a bottle in a stream, collecting a water quality sample, and sending it off to a laboratory to be analyzed, such as in this picture in the bottom left where someone's collecting a sample. However, DEQ monitors water quality in many different ways, and I have a few pictures here to demonstrate that. The top picture is someone monitoring stream flow, and this is very important because we use stream flow to calculate pollutant loads. And the bottom right, there's 2 people that are looking at fine sediment in the stream substrate. And Christy's going to talk about how this is actually done, our methods for that. In this picture, we have 2 people looking at what's called a grid. So finally, what is a TMDL? Well, it stands for total maximum daily load, and it is the maximum amount of a pollutant that a water body can receive and still meet the water quality standards. So I have 3 ways of describing this. You can think of a TMDL as a pollution budget. And the bottom left, I have a bar chart here, and the full height of the bar represents the total load, current load of a particular pollutant. And the pollutant could be sediment or lead or nitrogen or phosphorus. The green portion of this bar graph is what was determined to be the allowable load, the amount of that particular pollutant that the stream can have in it and still meet water quality standards. Therefore, the purple portion of the graph is how much of that pollutant needs to be removed or reduced so that the stream is then meeting water quality standards and the TMDL. In the top right, we have a donkey that's connected to a cart. However, this donkey is up in the air because there's too many packages on this cart for the donkey to be able to pull it. Therefore, we've exceeded the pulling capacity of this donkey. And in order for the donkey to be able to pull the cart, we have to remove packages. The more packages you remove, the easier it will be for the donkey to pull the cart. And this is the same as, you can use this as an analogy for stream health. Stream health, the more pollution that you remove from the stream, or the more pollutant that you reduce, the healthier the stream will be and the closer it will get to meeting water quality standards. And finally, in the bottom right, there's a picture of a bridge. I believe this is in Glacier National Park. Next to this bridge is a load limit sign that says 1 person at a time, which means that the carrying capacity of this bridge is 1 person. If more than 1 person is on the bridge, you may exceed the bridge's carrying capacity and it may break. The same is true with stream health. Too much pollution and you're above the water quality standards and you have an unhealthy stream. So how do we actually develop a TMDL? DEQ undergoes 5 main steps. The first being to define what the water quality targets are. What are our water quality goals? And those are based on the water quality standard. And Christy's going to talk about water quality targets for both sediment and temperature. The next step is to determine what the allowable loading rate is. How much sediment or how much water temperature can the stream have before it exceeds water quality standards. Next, we determine the sources of the pollutant loading. Where is it coming from? Then we determine TMDL allocations. We take that allowable loading rate of the particular pollutant and we allocate it to all the identified sources of that pollutant. And lastly, we develop water quality improvement recommendations and include those directly in the TMDL document. And now I'm going to turn it over to Christy. I'm going to stop sharing my screen and she's going to talk specifically about the sediment and temperature TMDLs. In her presentation, you will see lots of pictures of impaired streams, unhealthy streams. So pay attention to these pictures to note why they're unhealthy. And after Christy gives her presentation, I'm going to come back and talk about, so what does a healthy stream look like? And we can compare and contrast the 2 sets of photos. So I'll let you take it away, Christy.
Thank you, Christina. So I'm going to first talk about the sediment TMDL results. Sediment is a naturally occurring component of creeks. However, too much fine sediment can affect fish and other aquatic life by increasing turbidity or cloudiness of the water, blocking light, causing a decline in plant growth, and smothering bugs and fish eggs, filling pools or the deep areas of the stream with sediment and limiting spawning habitat. Sources of excess sediment include eroding stream banks, unpaved roads without best management practices in place, livestock access to stream channels, and lack of healthy riparian vegetation. And here's just some pictures from the Madison TMDL. We have a section of North Meadow Creek with exposed stream banks, a road in Hot Springs Creek with some ruts that can cause pathways that route sediment to the creek, sediment or cow access to a stream in Bear Creek, which can cause trampling and excess sediment in the stream, and an area of Hot Springs Creek that has been trampled by cattle. In Montana, there is a sediment water quality standard that says there can be no increase in sediment above naturally occurring concentrations, which will or are likely to create a harm to beneficial uses. And that beneficial use for sediment is generally aquatic life. At DEQ, we monitor the amount of fine sediment in riffles and pools. Riffles are the fast areas of streams and pools are the deep areas. And we also collect information about channel form and stability. What is the shape of the channel compared to what we would expect it to be under natural conditions? We also monitor those numbers of deep pools. As I mentioned, those can fill with sediment, and so the number of pools may decrease in a stream that has a lot of sediment. Here's an example of a grid that we use, that we place in the stream. And it basically has a number of areas that may intersect the gravel and the stream. We count those numbers of intersections that are over fine sediment, and we determine the percent of sediment in this manner. And we do this at a number of different locations to determine if a stream is impaired for sediment. We also investigate the sources of sediment. The three main areas that we investigate are runoff from road crossings and adjacent road segments, sections of road that are very close to the stream, erosion from stream banks, and the pollution buffering capacity of that streamside vegetation from upland crops. I'll just give an example of this. These are two pictures from the surveys that were conducted, one of North Meadow Creek and one of Ruby Creek, with gravel roads right up against the stream. So we went out and actually collected data at these areas to determine how much sediment was coming in from the roads. And we used models in order to estimate that sediment loading. We also estimated annual rates of erosion from stream banks. This picture shows a bank that is exposed. There's some roots, but a lot of the bank is not covered by vegetation, and we can take a variety of measurements to estimate the annual rates of erosion from the banks. We can also use aerial photos to estimate the amount of sediment entering from upland crops. So this picture is from Elk Creek and shows all the fields that are adjacent to the stream on Elk Creek, or adjacent on Elk Creek. And we actually measured the areas of these fields and determined how much vegetation was between the fields and the stream, and then used models to estimate the amount of sediment entering from these fields. Sediment TMDLs were written for these creeks that are given in yellow. And we also evaluated several creeks, but no TMDL was written, and these are in blue in this map. Ultimately, what we were interested in is the TMDL allocations as a percent reduction. So here's an image depicting this. On the left, we have a road that is well graded with crossbar in place to prevent sediment from entering the stream. On the right, we have a road with deep ruts and no crossbars in place. And then we wanted to determine what percent sediment would be reduced if we were to conduct practices to get this road that doesn't have crossbars and is rutted back to that desired condition. So how much sediment would be reduced if we put in those best management practices? And this was done for banks and upland areas as well. Now I'm just showing an example of what you can find in the document. The TMDLs is expressed as a reduction in annual load. And what we're getting at is reducing the sediment load will help to achieve the sediment water quality target of more natural levels that can support aquatic life. So here for the Elk Creek, we have the current estimated load, the amount tons per year from roads, eroding banks, and upland erosion to get a total load of 4,862 tons per year. We have the allowable load, how much we would expect if best management practices were in place. And this was 3,361 tons per year, and that's a 31% reduction. These results can be found for each of the creeks that we evaluated in the TMDL document. Now I'm going to move on to talk about our findings related to the temperature TMDLs. Elevated water temperatures can result in reduced dissolved oxygen in streams, increased algal fish. It can also make fish more prone to disease and promote survival of non-native fish, which can often thrive in warmer environments. What increases stream temperature? Lack of shade due to removal or reduction in native streamside vegetation, over widening of the stream channel, possibly due to removal of riparian vegetation, lack of cold stream flow as a result of irrigation diversions, and warm water irrigation return flows. So here's just another set of photos from the sampling showing an area of Elk Creek with not very much shade and exposed banks where the stream has been over widened, an area of Moore Creek where there isn't much riparian vegetation, and then a section of Elk Creek that in fact went dry during the surveys. The temperature water quality target for Montana relates to the state water quality standards that says where the naturally occurring water temperature is 66.5 or greater, the maximum allowable increase is 0.5 degrees Fahrenheit. So basically, we can't have a 0.5 degree Fahrenheit increase over what would naturally be expected. The problem is it's very difficult to determine what would be expected naturally because most streams are under a natural condition. So what we do is we have surrogate measures, which involves making recommendations of for shade, width of the stream, and stream flow, which we believe will result in the required temperature. So for shade, we want to get the stream similar to natural conditions. For a width-depth ratio, which is the ratio of the width to the depth of the stream, we also want that to be similar to natural or reference conditions. And then we suggest increases in stream flow of 15%. Temperatures are monitored using hourly temperature recording devices, such as this picture on the left with a brick that's holding the temperature monitor underwater. We also have flow meters to estimate stream flow, and then what we call a solar pathfinder, which you hold up while standing in the stream, and you can use the reflection of the above canopy to determine how much shade the stream is receiving. Temperature TMDLs were developed for Cherry Creek, Elk Creek, and Moore Creeks, and West Fork Madison River and Lower Madison River were also evaluated, but no TMDL has yet been developed because that would require much more complex modeling than we did for this investigation. Shade was one of the most important components to reducing temperature. And in order to evaluate shade, we compare the shade present using that shade meter to what would be predicted if riparian zone was in natural conditions. Choosing select monitoring points to measure shade along the creek, as well as using aerial photos. And here's just a map of Moore Creek with the mouth of Moore Creek up here, where my cursor's pointing up on the right-hand top of the screen. And we can see in yellow, these are the areas where the amount of shade was much less than what we would expect based on our models of what the natural conditions should be. We also conducted temperature modeling. We wanted to predict what temperatures expected given the current shade, stream flow, and shape of the stream, and then determine what temperature is possible given our recommended changes in shade and stream flow. So this is just an example of a result from Moore Creek, which is I'm going to talk about the section highlighted by this rectangle here on the map. And what we predicted for this section, based on the light, shade, and stream shape, was a maximum temperature of 78 degrees Fahrenheit during the summer of 2013. The actual temperature, maximum temperature, was 77.5 degrees Fahrenheit, so fairly close to that. What we predicted based on increases in shade and flow was 72.5. And the temperature that could be harmful to west slope cutthroat trout was 73 degrees. So by doing some of the suggested changes, we can actually get closer to that, which is necessary for cutthroat trout. In the document, you will actually find a table saying what is the amount of heat energy that would enter the stream if the shade, stream flow, and width targets were met, compared to what the existing heat energy is. And in this case for Moore Creek, that would be a 26% heat reduction. And we express this in kilocalories per day. However, this isn't very practical. Most of us don't really think about things in terms of kilocalories per day. So instead, what we want to think about is what actions get us to our target. And these are increases in shade and stream flow and increases in riparian vegetation. The table also shows which sections an increase in stream flow would be most helpful. And these are also provided for Cherry and Elk Creeks. So now I'm going to hand things back to Christina, where she will talk about improving stream health.
Okay, thank you, Christy. Oh, I'm having troubles again. Hold on just a minute, please. Okay, I apologize. Okay, so Christy showed you quite a few pictures of unhealthy streams and talked about what caused those issues and then what we can do to improve those streams. And I'm still having difficulties. Hold on just a minute, I apologize.
In the meantime, while we're waiting to deal with some technology issues, does anybody have any questions at the moment? You're welcome to raise your hand or type your questions in the group chat.
Okay, I apologize again. My computer keeps freezing up. How handy. So as I said, you saw quite a few pictures of unhealthy streams. So what does healthy actually look like? I have 5 pictures here of various streams within the Madison River watershed. Some of these streams are listed on the impaired waters list as not meeting water quality standards, but that doesn't mean that even an unhealthy stream might have portions that are actually looking pretty good and actually are healthy, even though overall it might be considered impaired. So what do you see in common with all 5 of these photos? All 5 of these streams and these particular pictures have healthy riparian or streamside vegetation, which is very important for the reasons that Christy talked about. Healthy riparian vegetation that's mature provides shade, which reduces stream temperatures. Healthy streamside vegetation also stabilizes stream banks. We don't end up with streams that are too wide. You can see in these pictures, the channels are pretty narrow and fairly deep. The difference with the picture in the top right, you see Odell Spring Creek. This is actually wetland vegetation as opposed to willows or shrubby vegetation. But this is still a very healthy stream system because wetland vegetation is very stabilizing of stream banks. So to contrast again, sorry, I apologize. I keep freezing up. Christy, to prevent this, could you please, I'm gonna stop sharing. Could you share the presentation and I will ask you to change slides?
Yes, I will do that.
Thank you. Yes, that's good. Thank you.
Oops.
Okay, next slide. Thank you. So to contrast that, again, I have 2 pictures here of Wigwam and Moore Creek. And I just want to demonstrate again the difference in the health of these streams. A lot of people might look at this photo on the left and not realize just how unhealthy this segment of the stream is. And what you see here is you have a very wide channel that's very shallow. And part of that problem is, or the reason that's caused, is because there's no healthy streamside vegetation here. We only have grass that's been heavily grazed. So that's not stabilizing vegetation. The channel has become over-widened. There's no shade provided here, so stream temperatures are most likely elevated. You'll also see in this picture that we have several cows that have complete access to the stream, and that's most likely the cause of why there's such unhealthy vegetation. The same thing with this picture of Moore Creek. You can specifically see eroding banks, and this was because cattle have access to the stream and they've trampled those stream banks and heavily grazed the riparian vegetation or streamside vegetation. We also have a completely dead willow here. So this is not at all a healthy system. So next slide, please. So how do we go from these unhealthy streams to get to a healthy stream? Well, as we've been talking about, the key really in the Madison River watershed is healthy streamside vegetation. And the number one factor that can improve stream health for most streams in the Madison is improving riparian grazing management practices. Now, we realize that not everyone in the watershed has livestock, whether you have your own livestock or whether you're a rancher. We realize that's not always the case, but everyone can still do their part to improve stream health. If you have property that's along the stream, like a lot of people may be living in town along Moore Creek, you can keep native riparian vegetation along the stream. Christy had a picture in her presentation of Moore Creek where one side was wooded and the other side had lawn grass all the way up to the stream's edge, which is not stabilizing vegetation, and it didn't provide any shade to Moore Creek. There's other practices as well, which is, well, I just talked about urban streamside vegetation management, but also we recommend education on responsible streamside recreation. So I'm guessing a lot of you and a lot of people you know recreate along the Madison River and some of its tributaries. So a key there is once you're in the water is to stay in the water to protect that streamside vegetation, as opposed to constantly getting out, especially if you're a fisherman, and creating all kinds of paths along the stream that damage streamside vegetation. On this slide, I have a few pictures. These are not in the Madison, they're just example photos of various management practices that can be done to improve stream health. The top picture is of a fence that was recently installed. And the purpose here is to limit livestock access to the stream corridor and allow this vegetation to rebound and become healthy again, which will in turn add all of those benefits back to the stream of stabilized stream banks, channels that will narrow because the stream banks are stabilized, and then we have that shade providing vegetation. And the bottom left, this is called a water gap, and it might be a little difficult to see that there's actually a fence there where that cow is standing, but that's referred to as a water gap because that's the only access that cow has to the stream. You'll notice on either side of that fencing, we have tall, mature vegetation, and you don't see any eroding stream banks. But where the cow is, you see very unhealthy vegetation, and you see a very, very clear eroding stream bank. And the picture in the bottom right, this is also regarding livestock. It's another way to keep, in this case, cattle off the stream to keep them from damaging stream banks and that riparian vegetation. And this is called off-site watering, which is just to provide an alternate source of water for your livestock. And then on this slide, I also have in here irrigation water management as another practice. And Christy talked about this as the goal, when practical, is to leave more water in the stream so that we have cooler temperatures. Next slide, please. So now we know how to get to a healthy stream, but we also know that these practices, full-on restoration projects, as well as just changing your land management practices, can be very expensive. So how do we pay for this? Well, there's various grants out there. Some are offered by DEQ. other federal and state agencies, as well as some nonprofit groups. And these grants are available for government and nonprofit groups such as conservation districts, local watershed and conservation groups like Trout Unlimited, for example. These groups work with private landowners to get projects implemented on private land, but there's also funding directly for private landowners through NRCS, the Natural Resource Conservation Service. We also at DEQ work with federal partners such as the U.S. Forest Service and the U.S. Fish and Wildlife Service to implement projects on federal public lands. Section 9.7 of the TMDL document outlines various funding opportunities for all of these different organizations and entities if you're interested in exploring this. Additionally, staff at DEQ are available to assist you with navigating this to help you obtain funding. And we also provide expertise on restoration projects. And here I have a picture that the Madison CD provided us a few years ago of a restoration project on Jack Creek. Next slide, please. And from here, I'm going to let David talk about ways that you can get involved and about different projects that the Conservation District has going on. And I will let David share his screen now.
Thanks, Christina. A moment here. It says I cannot start screen share while the other.
All right, now you can.
All right. Yeah, thanks again for letting the Madison Conservation District provide a little bit of background about some of the work we do at the CD and how we've been involved in this process. So again, yeah, I'm David Laufenberg. I'm with the MCD, and I just started this past January. Brief history of conservation districts. So essentially, we're set up post Dust Bowl for soil and water health, soil and water conservation. The feds mandated that each of the states figure out exactly how to approach their conservation districts. And in the state of Montana, generally those conservation districts follow watershed boundaries, but not always. As we can see in our case, we have Madison County actually outlined in dotted green, and then the Madison Conservation District is wholly encompassed within Madison County, and that's dotted in red. We also share within the county Ruby Valley Conservation District to our west, and then actually a pinch of the Beaverhead and a pinch of the Jefferson Valley Conservation District also work within Madison County. The lion's share of the Madison, though, certainly falls within the Madison Conservation District. And so that's certainly our focus, being based out of Ennis, Montana. Our tagline is local common sense conservation. Certainly historically, largely our stakeholder group was driven by the ranching community. For the most part, that continues to be the case. My board is made up of 7 volunteer citizens in the Madison Conservation District, and most of those folks come from a producer or ranching background. And so actually that, I think, dovetails really well with this TMDL work, because as Christina pointed out, the lowest hanging fruit is to work with this largely ranching community to facilitate better riparian practices and management practices. We've certainly had some successes in the past decade within the conservation district. Seems like every year or two we pull off a pretty significant restoration project on one of the tributaries of the Madison. We're in the process of wrapping up another one on Jack Creek actually right now. I'll be out there tomorrow, both doing water monitoring and also checking in on 242 willows and 22 cottonwoods, and chatting with those landowners as I do with every visit to ensure that the water regime is being upkept. And this time of year, of course, water deficit is the big concern in August, but so far things are looking really good. Additionally, this TMDL work facilitates sort of a larger and longer term vision document associated with how we approach watershed restoration in the Madison Valley. And so the state recognizes that as a watershed restoration plan. That's something that my predecessor, Ethan Cunard, started a little over a year ago. And we'll be working on that for another year and a half or so. And a lot of what's in this TMDL document will be reflected and help inform that longer term planning document. Specifically in Montana, conservation districts have one regulatory function to enforce the 310 law. So that's really any work done within a natural stream, and including the adjacent land, so essentially the banks, weirs, bridges, culverts, stream restoration, that sort of thing. And of course, these sorts of projects generally impact temperature and particularly sediment. As Christina pointed out, we have been producing one of these annual reports from Madison Stream Team data, which is a citizen science-led effort. We're in our 11th season now. So it's pretty cool. It's a unique season to be doing citizen science monitoring, but so far we've been able to get out on one of the tribs every week, and so continue with some baseline monitoring of the tribs. Additionally, this year, we're actually going to try a tributary blitz day. So sometime in the next month, it'll probably be the latter half of August or early September. We'll actually visit each one of the tribs that DEQ studied, so the 20 or 21 tribs that they've talked about today, in addition to a handful others. And we'll just try and get sort of a snapshot in a single day, what's every trib sort of looking like from some of these baseline environmental metrics that reflect river health. So that'll be a pretty cool addition, I think, to some of our monitoring efforts. A lot of folks are familiar with the Christmas bird count as like a single day effort, or like a BioBlitz, where people go out and count all the flora and fauna within a given geography in a day. So it's a similar idea, but specific to the tribs of Madison watershed. We also have a pollinator program at the Conservation District. We're going to be getting a bunch of seed this fall. So if you or anyone you know might want some pollinator seed to start their own pollinator garden, we'll have heaps of it. And then we'll do monitoring associated with those pollinator plots also. As I mentioned, we've been mostly, historically working with ranching community. And so we actually act as a bit of a community equipment locker for a number of things. We can see here a rotary harrow that has an air seeder mounted to it. And that's pretty helpful for covering up exposed soils or replanting pasture land and that kind of thing in the county. We also have a suite of education programs. We've got a GROW program, which is tied in with the local school system. We hold technical workshops from time to time. For folks that actually are interested, this early October, we're just in the planning stages, but almost certainly we'll be hosting a low-tech restoration technical workshop out in the field. So like a field day in early October. Essentially beaver dam analogs and other lower tech restoration, low hanging fruit for river health. And then we also do field trips to various restoration projects and just sort of showcasing different pieces that we've been involved with. Yeah, that was maybe a little more than 5 minutes, but pretty short and sweet. Thanks so much. These are a couple photos actually from the Jack Creek restoration from May, this past May. Thanks so much.
Thank you, David. Christy, if you could please share your screen again. Great, thank you. Okay, next slide. Okay, I want to quickly go through how the TMDL document is organized. Again, here's a cover page of what the document looks like. Next slide. The document is divided into 3 main parts. The first part is introductory information, and that is the information that I gave at the beginning of this presentation. There's more detail and a project overview, a full description of the project area. The sediment and temperature water quality standards are discussed in section 3, and there's in-depth information about how a TMDL is developed in section 4. Part 2 is the portion of the presentation that Christy Meredith gave. This is the total maximum daily loads. This includes water quality monitoring data, our source assessment methods, and the actual TMDLs and allocations. Also in this section is all written comments that we receive will be included in section 7, as well as DEQ's response to those comments. And the most important part of the document is part 3, the water quality improvement recommendations. And section 8 talks about water quality impairments that are related to sediment and temperature. Section 9 is the water quality improvement plan, which includes the water quality improvement recommendations. And section 10 gives information about monitoring for any future monitoring that's done in the watershed. And then to supplement this, next slide please, we've created a stream summaries document. Now, this isn't out there for review yet, but it will be available when the TMDL document is finalized and published on our website. And Moira has already put in the chat box a link to the TMDL webpage where you will be able to find the final TMDL document and this document, the Madison stream summaries. Next slide. This document will include a 2-page summary of all 20 tributaries that we looked at for this project. There's also a glossary at the back of the document that covers all the basic water quality terminology that we use in the stream summary document. And there's also one in the TMDL document in part 3, if it's needed to help read through that section. Next slide. This is an example of one of the stream summaries. This one's for Antelope Creek. All stream summaries that you see will have a problem description of the main problems for that particular stream, what basic solutions are for those identified problems, and then DEQ identified restoration project locations. Each summary will also have at least 3 pictures of the stream that show either specific problems that were identified or healthy sections of the stream to point out both sides. On the right page, you see on the bottom a map and a table. So for every stream, we've included on the map all of DEQ's monitoring locations. Additionally, if we use data from the U.S. Forest Service, which we did for sediment, their monitoring locations will be shown on the map, as well as the Madison Stream Team's sediment and temperature monitoring locations. And the table at the bottom gives the latitude and longitude of all of those locations and identifies what was collected at each location. The table at the top of this page helps inform the watershed restoration plan that David talked about. These are the pieces of the TMDL document that feed into what's called the WRP. Next slide, please. How to submit comments. You can submit comments 3 ways. You can either do so electronically at the website, that web link given there. Moira has also posted this link in the chat box. You will also find it if you received an email from me regarding this meeting, you will find that link. You'll also find the link if you saw the notice in a legal ad in the newspaper, you'll see the link there. You can also mail your comments directly to us at that address. or you can email them directly to me. Again, comments are due by 5 p.m. Thursday, August 20th. Next slide. So what happens after we receive all of these, after the public comment period ends? We review all the written comments that we receive, and we make necessary edits to the document to address those comments when necessary. We also write responses to each comment that we receive, and as I said, those are included in section 7 of the document. Then we submit the document to the U.S. Environmental Protection Agency for approval, and Peter Brum is on this call. He introduced himself as EPA representative, and he'll be reviewing the document for us. Upon approval from EPA, the document gets posted on our website. At the same time, the stream summaries document will be available. Again, this link is in the chat box as well. And then finally, once the document's out there, we hope that it is used to guide water quality improvement plans and practices in the watershed. If you have not received an email from me about this project and you would like to be notified when the final document and the stream summaries document is available, you can enter your email address in the chat box and I will add you to our distribution list. And with that, we will take any questions that you have.
Please keep in mind that you can use the public comment link in the group chat. This is just for Q&A on the presentation that we just saw. So if you have any questions, you can unmute and ask. I think we have a small enough group, or you can type them into the group chat.
For temperature, do you look at effects of global warming and ways to mitigate that?
So that was not specifically looked at. One thing that I did do was for the year that was modeled, it was 2013, which was one of the hottest years in the last 20 years. And so I believe that is more representative of, the worst case scenario. But we did not specifically talk about climate change in the document.
So Kathy's asking the question, have you had helpful comments in the past?
We most definitely have. We've received very good feedback from the public on our projects before. I see your follow-up question of, can you give examples of that? Yes, we have very knowledgeable people that have commented on modeling methods, for example, or they've looked at factors that we've used in the models to kind of fact check us a little bit to see, for example, one of the things that we use in our models is to look at, sorry, I was reading a comment, to look at the types of vegetation that are used, types of vegetation or ground cover that goes into our models. And sometimes we'll get feedback from our stakeholders or the public on whether or not we've got an accurate description, for example, of the type of vegetation that we're using in our model for buffering capacities. Other examples, sometimes people come back and tell us, hey, you missed some data. Like, there's some data out there. Did you know about this, for example? Those are two examples that come to mind right away. But in general, yes, we get very good feedback sometimes, and we really appreciate those reviews of the document. It makes for a stronger document.
Kathy's saying, thank you, that is helpful. And thank you, Rich, for your question earlier. And we see that you have a request to be added to the email list, so we'll make that note. Does anyone else have any questions? You're welcome to unmute yourself or type a question in the group chat. And if you're on the phone, you should be able to just unmute via your phone or by hitting *6.
This is Christy Fortman. I'm just going to follow up to Kathy Jean's question. Usually we try to get most of that feedback and input from the public as we go along the process, so that by the time it goes out to public comment, it's been reviewed by multiple eyes and we've caught a lot of that stuff. But yeah, I mean, if you see something that you think is a little off or something that we missed, please go ahead and submit that to us.
Thank you, Christy. We'll wait for a few more minutes to see if someone else has a comment or a question. We'll stick around to answer those. We'll be glad to. But thank you to everyone for joining us. It's really great to see so much participation this evening, and we really appreciate it. And we look forward to seeing any comments that you may have on the document. If you have any trouble downloading the document or submitting comments, please contact me. I will enter my contact information in the chat box.
Thank you everyone for joining. You're welcome to jump off if you feel like you had your questions answered. If you have additional questions, like Christina mentioned, we'll stick around for a few more minutes. Great. Well, thanks everyone for joining us. At this time, I think we'll wrap the meeting up. You have contact information and feel free to reach out if you need anything.
Thank
Thank
you.
you.